Hi folks, thanks everyone who decided to join us today and everyone who I cannot really see. So we know that we are the last ones separating you from the after party, so we will try to make it entertaining and not go much over time. So the story that we are going to tell today is called Making Every Minute Count, how Nimses scale its mobile platform on Google Cloud. And well, the clicker doesn't work. Oh, no, it does, but it doesn't reflect there, sorry. So, our goal today is to tell you the story of a rapidly growing startup, a digital native company with mobile apps and all the great stuff, that was migrating into Google Cloud and using specific services, specific technology to help them move faster and develop better. So our goal today is to get you share some inspiration, some battle stories on how it feels and what you can expect and what you can achieve and how it can help you spend less time developing technology when someone else already has it, so you can focus on developing the product. We already had the introductions, so just in case, again, I'm Dmitry Novakovsky, I'm Cloud Sales Engineer. I work out of Google Amsterdam. You see my email on the screen in case you will ever want to ask something. Ivan, a few words.
Yeah, hi guys once again. My name is Ivan and I'm a software engineer at Nimses core team, and I was responsible for developing a few generations of Nimses infrastructure and led migration from the Amazon to the GCP, and today we will share with you our experiences.
Sounds good. So, before we move forward to actual experience, I think that most of you don't know what Nimses actually is and what sort of product it is. And since we're in this movie theater today, we will try to do something fun. Guys, is there a way to actually get rid of the picture of me and just do full screen from the projection? No? No. Okay. Well, look, I want to show a video, but it will be like this. Can we do it full screen? No. Okay, let's do like this. So. And we have no sound. Why? Why do we have no sound? Guys, can someone help me with the sound? Because apparently it's trying to go through HDMI or something. Yeah, headphones, I see it now. It should be fine now.
The pure digital asset. 1 minute of your life. You get 1 NIM for every minute that you live. You are connected to all others. All the NIMs of all the other people shape Earth's Nimonomy. Earth is your home. Your home is made of temples. You are in the temple, and it will never change its size and its location. By living, you contribute to the global treasury of human life. The treasury is the quintessence of Nimonomy. The ark for future generations. You are the first to enter the future. The highest value of this future is 1 human life. Infinim. The perfect and most precious asset made up of 63 million NIMs. And you can hold it. It will make you wealthy in the one and only world. The world with one and only version of reality. The world with one and only open truth, protected by worldwide blockchain. You are the first to be completely free. You are the world. The world is you.
Okay.
So it was supposed to make things clearer, but I hope you guys liked it. So, one more time, what is Nimses? From technical perspective, it's a mobile social platform in which people interact with each other using the mobile app on Android, on iPhone, obviously. It's geolocation based, and it's also based around the notion that every user of the platform is getting kind of capturing every minute of time spent in the app in a form of this digital value assets, so that like all the things within Nimses are marked and measured in Nims, like likes, posts, transactions, buying goods, and so on. It has more than 6 million users as of now, and more than 100 microservices developed by Ivan and his team. So with this in mind, Ivan, can you tell us a bit how did you guys start it technically?
Yeah, we started as everyone's starting. We started with a small team of 3 engineers, a couple of microservices written in Go, and interconnected with a gRPC based on the Go kit, backed with the PostgreSQL database, allowed us to develop and use the geolocation indexes and text search indexes for making our application to happen in the beginning. And then everything was containerized with the Docker and orchestrated with the Docker Compose ran on the Amazon. And in the first week when we opened to the users and to the world, we obtained 3 million users in the first week, and we spent the whole week fixing bugs and fixing something that was related to the PostgreSQL optimizer 3 grams and geolocation special specifics. And after that, our first generation of the infrastructure was handling 50,000 QPS to our backend system pretty gratefully. But from that point, we started to think how to move further. And under further, I mean how to scale from what the scale limit we had to the somewhere beyond 100 million users.
So that was the ambition with which I actually met the guys about a year and a half ago. And it was pretty much we need to scale up without scaling the team like linearly to the amount of users that they wanted to support. And within this ambition, there were like 3 key components. So one is they wanted managed infrastructure. So they understood that the more microservices they will get, the more users they will get. They don't want to be responsible for running things which are hosting these microservices. The second one, and that's the one's personal, is horizontally scalable NoSQL. So they were coming to the point of not doing everything in PostgreSQL anymore. So the idea was to have the database that would be able to fulfill the growth ambitions and at the same time be simple to develop with and simple to operate, like hopefully no operation at all. And the final one was something to handle the distributed transactions, because you've seen this part with blockchain and, well, I mean, it has to be global, it has to be for all the users all around the world. And again, you don't want to kind of put it into single PostgreSQL instance. So with this in mind, we started, yes, we did start, right? We started adopting Google Cloud at Nimses, and the first point was obviously managed Kubernetes. The guys had their minds set on doing Kubernetes right away, so it was not a question of choice. Plus, it's like the standard pretty much in the industry right now. And the quote below is like, we lost a few nodes in one availability zone last night. No human impact, all things recovered on their own. So that's pretty much the experience which the team is getting right now. So they are configuring Kubernetes to some extent, but they're not managing it. They're not managing uptime. They're barely managing upgrades and so on. So it's 2018 now, so we will not be spending time talking about why microservices, why containers, and so on. The point I'm trying to make is that at the scale of 100 plus microservices and growing users numbers and so on, you will need, and we will need, and they needed container orchestrator. And the choice was obvious, Kubernetes, like was said. So, like some of you know, so let's set a bit of context. Kubernetes, on top of the standard containerized workload, gives you automation on scheduling and scaling pretty much, and also integration with the underlying primitives like networking and like storage. So properly deployed Kubernetes application doesn't require you to manage the upgrade of the workload, doesn't require you to manage the amount of containers which you need to run, doesn't require you to make the decision on which server to run a particular container. But at the same time, doing Kubernetes like your way on one, so not without using managed services, creates additional overhead of actually running Kubernetes. So installing it, making sure that you have enough nodes, that they are upgraded, secure, that unhealthy nodes are replaced, and so on. So that's why actually all public cloud providers today have the managed Kubernetes offerings. With Google Cloud, we've been doing it for quite some time, and that was fitting pretty well to the ambition of the Nimses team to get into managed infrastructure. And to the also to quote of our highly respected developer advocate Kelsey Hightower, who writes the book about doing Kubernetes the hard way. So it's supposed to for you to like read it once and never try to do it again, just like use a managed service. So now we will go through a few lessons and like practical experiences of what it felt for the team to adopt Kubernetes. And remember, they didn't do container orchestration before. And Ivan, can you tell us like what was the feeling of the development team when they were first exposed to this?
Yeah, when the first time you meet the Kubernetes, you have to learn the basic building blocks like ingresses, services, and etc. And there can feel like something a little bit complicated for your developers. And you want your developers to concentrate and focus on the development of the application, not in the infrastructure. And when we were starting with the Kubernetes, we were ought to write a lot of manifests manually, which are verbose and not related to the configuration of the applications itself. So we wanted pretty hard at first to move away from it, to simplify it, somehow make it reusable. Dmitry.
That's how they found Helm.
Yes. And the first thing which everyone is making when moving to the Kubernetes is adapting some kind of the package manager like Helm, which what we did actually. And the package manager allowed us to make the reusable templates and separate the configuration for the infrastructure, which is related to the Kubernetes basic blocks and the application.
So the idea with Helm is that you get to expose only necessary set of parameters to developers. Instead of having them maintaining this whole thing, they just get to see the parameters which they are responsible for in scope of particular microservice. And that's exactly what developers in Nimses actually wanted. The fun part is that it kind of resulted in getting to this stage where operations and development were effectively decoupled. So developers would be responsible for this one manifest called Filus YAML, and the ops team would be responsible for everything else, for configuring ingresses, which are load balancer controllers in Kubernetes, for configuring replica sets, which are defining how many instances of particular service you have running in the cluster, keeping everyone happy with their particular duties. It was interesting for me to observe because it's one of the two patterns which I usually see in the teams. In some teams, they use Kubernetes to decouple things. In some teams, they use Kubernetes to kind of merge together the development and operations teams without having a clear boundary anymore. I wonder like what is the pattern, what is the rule here, but well, that's what guys in Nimses did. Ivan, how did it feel? I know that you guys are very concerned with security and you spend a lot of time making sure that the things that you're doing are secure. So how did the introduction of Kubernetes and managed microservices impact this?
The introduction of the Kubernetes helps you in one way, that the Google and the best security engineers in the world will set it up for you. But it's easy to forget about how much of the different cool tools the Kubernetes gives you it's easy to forget behind that the security still matters, and you have to think about it and manage it manually and explicitly when you deploy and containerize your applications. And from that standpoint of view, you should not forget to manage the security. And the advice here from us is use the best practices which is described rapidly on the internet. And the second one, there are a lot of linters and open source tools which can lint and check your manifest, deployments, and Docker files against the various non-security holes. For example, like running your application from the root users is a very common thing, and limitation of resources is the second common thing, and others. Use them and be secure.
Secure and prosper. Well, besides audit tools and the best practices from the community, there's also vendors like Google Cloud, like other clouds as well, who are usually interested in keeping the customer secure. So in Google Cloud, we have the white papers, and we actually have tools like binary authorization, for example, which we really kind of encourage everyone to look at and make sure that not only the infrastructure layer is secure, which managed service takes care of, but also the applications which you run on top of Kubernetes. And now my favorite story. The first day of production rollout.
Yeah, we were so happy with our automation and of the operation and the management toil of the infrastructure for the microservices that we switched the whole traffic once for the first time. I mean,
because they are very brave.
Yeah, first 100% of the whole traffic to the new Kubernetes cluster that was so ready to accept new users, and the users suddenly start to receive the errors about the authentication, and we had to firefight the ingresses configuration live. So the advice here, do canary when you do releases.
Yeah, there is no need to expose all the users to danger right away. So in terms of the next iteration, again, I'm working with the team actively and observing what they are doing. The Kubernetes part is pretty much the solved issue right now. And the next stage for many companies adopting Kubernetes, including Nimses, is to introduce Istio. So what Istio is doing is it provides the connective tissue for the environment where you have hundreds of microservices, and they can also be polyglots, so working on different languages. And what Istio is doing is it lets developers offload some of the common tasks, like for example mutual authentication or traffic steering, when you can use very granular numbers of how much traffic you want to point into the new version, or service tracing, when you want to know which services are participating in particular user requests, and where do you get latency and where do you get errors. So integrating Istio into GKE environment allows you to offload these tasks into infrastructure, because it's a common task which doesn't need to be handled actually on application layer, and get into a more predictable and controllable microservices environment. So in Google Cloud, we actually have right now the alpha program for managed Istio. So a checkbox and you get it on your Kubernetes cluster. And that's what we are working with Nimses team to adopt. With this, let's accelerate a little bit because we have two databases more. Let's talk about Datastore. So Datastore is the database, the managed NoSQL database, which Nimses team right now is using to host sort of many generic services like user feeds, like chats, and so on. And the point about Datastore is that it's fully no-ops. So you don't have to manage storage, you don't have to manage virtual machines, you don't have them. You only have the quota on how much QPS you can put on the database, and you have the pay-as-you-go or pay-per-use model where you don't pay for infrastructure, you pay for the amount of storage you consumed and amount of operations you've put into the database. So it's like G Suite, it's like Google Docs, but for your database. And this is working fine for the guys now, but there was a learning curve. So Ivan, can you tell us about the learning curve a little bit?
Yeah, there is a learning curve when it comes to the NoSQL databases, especially managed, from the relational world. When you control everything and you know how everything is built behind the scene. But with the NoSQL, and especially when someone manages it for you, there are a lot of nuances of the architecture. And to build effectively your application and use the benefits which this database can give you, you have to learn pretty excessively the nuances and limitations and the architecture of the database you are going to use. And that was the case for us. For example, the Datastore provides you a totally horizontally scalable database. But there are a lot of limitations and nuances on the level like, for example, unusual transaction isolation, like read committed but not read committed exactly. The eventual consistency and strongly consistency mixed modes in different read operations. You still have to think about that you don't hotspot a single route or keys and distribute your load evenly. So you have to think about how you pick keys, how you organize your data, how you lay out it. And for us, one of the greatest limitations was, for a few services, the limitation which comes from the architecture of the Datastore, that it has the limit of the mutations count, which could be done in 1 second. You can't perform more than one mutation.
You can do more than one update per second for an entity key. So like for one key.
Yes, for an entity key. So few of our services had to aggregate the changes to work around it, or shard the keys and counters, for example, when, for example, we count the edges in the social graph, and we had to work around it when we were rewriting our services to this database.
Yep. So then when you learn the managed NoSQL way, there is the next step, and this is my favorite one. In managed database, what you can end up with is that it takes more time to see that your software actually has bugs, because the database just works. It accepts whatever you do to it. But then at the end of the month, you see that you're doing much more reads than by design you're supposed to do, because you have like a much higher bill for the database services. So here, one of the things which guys are pointing attention to is that they have put a caching layer in front of Datastore to make sure that if something unexpected happens and all of a sudden your code is putting more reads or more writes into the database will feel fine. You can put like 10x more from what's 100x more from what is designed. But at the end of the month, you will see the increased bill. So it's better to at least cache the ones which are obviously wasteful. Okay, and that's one part of the story. Another part of the story is that you have to observe very closely with the tools which our managed services are giving you, and sometimes they are very different and maybe even limited compared to what you do with standard MySQL, what is actually happening within your database. So like in Nimses' case, with this situation with increased monthly bill, we needed the visibility into what happens in specific kinds, in specific entity groups, and in specific indexes. And what we found is that by default, these stats are not very much exposed on UI. But if you work closely with Google, if you work closely also with Google support, there is a way, and we found a way, to set up the export of granular reports, based on which we were able to do the dashboards, which you see on the right. And based on that, actually see the spikes and kind of correlate it with product releases and see which tables we are getting excessive use from, and optimize it and fix the bugs over there. Another thing is backups. So the funny thing is that in managed databases, you often don't need backups to protect against infrastructure failure, because cloud gives you very high SLA for redundancy. So it's not like you can use your MySQL server, lose your MySQL server and lose all the data. But you want backups to protect against your own mistakes, against bugs which can corrupt the data which is running there. So there are managed backups for Datastore, but you have to be careful with them as well, because it's hard to do incremental backups for such a service. So you have to export kind by kind and find the right cadence of doing such kind of backup procedure. Back to you, Ivan. Tell us about the indexes and the data model.
The indexes is the most complicated part in the Datastore to manage properly. The index doesn't, as far as I know, doesn't affect the performance, because the secondary indexes replicate asynchronously. But they affect the space storage and the latency of the eventual consistency, so you have a trade-off when you choose what fields to and properties to index or not. And for us, there was the biggest issue, or the problem was that to manage the migration strategy for the data, when you add or remove fields from existing models, which is already written to the storage. First of all, the driver by default can marshal back the models or data if it finds out the missing or unknown fields, and you better think in front or in advance about it, not to put yourself in the situation we put. And the second thing is reindexing. For example, when you want to switch the index off or on the field, you have to somehow reindex the whole of your data set. And for that, there is no automation tools. You will have to write it yourself. And there is no observability of what is the index fulfillment over your data. This sometimes complicated, especially when you, for example, at the beginning can forget about that the read on the non-existing index will return nothing.
And remember, this guy still likes Datastore. He's like a fan of supporter. So eventually, right now, again, I'm observing that the guys ended up using a combination of data services, and it makes sense. So you don't have to put everything into one PostgreSQL. I'm seeing some companies trying to do that, but well, if you're in the cloud, there are so much better options. Like Ivan already told us, most of their backend services are using Datastore. The geospatial queries are still on PostgreSQL because nothing does it can do it better so far than Postgres extension. The blockchain is on Spanner, and we will tell it in a minute. And all analytics are in BigQuery, so it's quite easy to export data from Datastore or Spanner or other systems which can just stock pubs up into BigQuery. And the next logical step for Datastore adoption is the new product, which is going to be released early next year. Right now it's an active beta, so you can also use it, called Firestore. And it has many features. It has the mobile side of things, it has the backend side of things. But in case with Nimses, the important part is that Firestore will have the API compatibility with Datastore, and it will be gradually migrate. All the database will be gradually migrated into this new backend. So again, no ops. The guys will not have to do anything. And as you can see on the slide, it will remove a number of very significant restrictions which Datastore is putting on the usage right now, especially eventual consistency. Since it will now work on top of Spanner, it will be all the queries will be consistent by default, and the limits into transactions and entity groups. So with the API compatibility for Datastore expected, I'm very much looking forward to see you guys actually adopting it. Maybe you will move the blockchain to it, who knows. And with this in mind, and the clicker works only like this, it's interesting. Let's move to the final bit, is Cloud Spanner. So Cloud Spanner is, maybe some of you have seen my last year's talk. If not, you can go and watch it on YouTube or other people's talks about Cloud Spanner. Cloud Spanner is used to back Nimses blockchain, and blockchain implementation in this case was used by the team to ensure that all the transactions in this internal system currency would be handled with trust, with transparency, with governance, and in a scalable and highly performant way, so that it can be actually, so it can be not just like some sort of in-game currency, but something that is reliable and can be audited also from outside. So all the transactions within the systems are written into blockchain, which is hosted by Cloud Spanner. And Cloud Spanner, well, it's a relational database, and I will let Ivan comment on why did you guys have to choose it and not just put everything into Datastore.
The main reason we choose Spanner for implementation of our financial component is the consistency model and guarantees for the transactional commit. The Spanner guarantees the external consistency for the transactions, and that was our main requirement for our service. Dmitry.
Horizontally scalable reads, why don't I? Okay, anyways, it's a relational database that runs in the cloud, and which, well, I wouldn't call it no ops, but it's fully managed. So you have the control to add and remove nodes. But the replication, the horizontal scale, both for reads and for writes, is handled automatically. So it's much easier than to run a cluster of whatever, PostgreSQL. And with this in mind, again, we work closely with Nimses and with other folks in Google to help the team get what they were expecting from Spanner in terms of throughput and in terms of the operational performance. And that's where, well, you see on the picture, it's important to read a lot about things. And Ivan is the guy who pretty much read all the documents. So tell us about your experience for optimization.
Yeah, the Spanner, as you know, is a relational database, and in that sense, it doesn't differ pretty much from what you may be used to in running and working with the MySQL and Postgres. But as usual, at first, you adjust your models, choosing the primary keys, and maybe introducing the interleaving of the tables, setting up the data layout for optimizing the queries across it. Then you optimize your queries because, you know, the Spanner has the SQL language for making the queries. And the third one, you optimize the transactions, which are expressed in a native API. And we had a great story related to that iteration of optimization when we had to heavily optimize our main operation of transfer between the users of the value or the asset. And in order to optimize it, you have to remember that the transactions are executing over the distributed environment and that all the data is distributed across the machines. So coordination effort requires a lot of work. And in order for the Spanner to make the transaction very performant, you have to reduce the number of splits that are participating in the transaction execution. For that, you just count your reads and writes mutations of the data inside of the transactions, and then remodel your data and remodel how the operation looks to reduce actually the number of operations or splits that are participating and coordinating for the transaction to be committed. And we successfully did that, optimizing our transfer operation for up to 3 times for the latency, literally.
So, true story. And as soon as the team got to the necessary number, we started looking at the operations again. And like I mentioned earlier, Spanner is not exactly no-ops operation, but it's fully managed. So you still have responsibility and the control into adding and removing nodes into the cluster, but nodes are not the virtual machines. So if you see that the database size and the load has gotten to a certain level and the CPU load goes above recommended 70 to 75%, you can always add the node from the UI without getting into any downtime or anything like that. And Spanner will automatically rebalance the data. So it will get additional storage capacity. It will sometimes copy, sometimes just reattach the data to the new node. And you will just see that, okay, I added the node, and after a few minutes, my CPU load went down. Also, in terms of the operations, we talked about Datastore backups. With Spanner, it's actually easier because this year at Google Next in US, we shown the managed backups for Spanner, which are integrated in the UI and they use Dataflow pipelines underneath. So it's much easier to constantly stream the changes into the cloud storage bucket and transfer databases here and there. But as Ivan already mentioned, at the beginning, you'll spend a lot of time, and we spent a lot of time actually optimizing the data model for the evolving business requirements. And there was a lot of usage for the native Spanner API because that's the way to actually gather the profiling and stats on transactions properly. Which brings us to one of the final points. How does it feel to use SQL in Spanner?
Yeah. I would be happy to tell you because we don't use the SQL at the Spanner because the SQL in the Spanner more about the OLAP. Yeah,
analytical.
Analytics. I mean analytics. Yeah, and we are more doing the kind of transactional thing, and the transaction expressed in Spanner in terms of the native basic operations like read this data, read this read row, and mutate this row. And we are not using that, but when you're using actually the SQL in Spanner, you have to remember the one very important thing, that there is no optimizer which will choose the index or proper join type for you based on some heuristics. So remember about that and be happy.
So yeah, making just to complete on SQL in Spanner as of now, also with a few customers who are starting to adopt Spanner, you can use SQL to do some of the analytical workloads. You can use SQL during the development and during the testing, but in practice, any real new development is better handled by the native API. So that's important to understand. And like sometimes people come to Spanner with the expectation just take the existing MySQL workload and move it there and get a horizontal scale. Doesn't work like that. You will have to invest in engineering, but eventually you will benefit from something that works better, faster, and scales to numbers which you wouldn't ever get with MySQL. And the final point, the final bit. Oh, that was nice. The final bit, your favorite bug with external state.
Yeah, the coolest bug we had with the Spanner was related to the transactions, actually. The transaction, as I said, they are expressed as the computation, and the computation is expressed or can be expressed as the lambda function or anonymous function of the closure. And in that sense, you can write the computation which uses the external shared memory. And then you could find out suddenly, or forget about it just, that these transactions, when they are being committed, they can be aborted or restarted. And here lies the very important point you have to remember about, that your invariance about the state must be held in between those restarts. And that's related to the bug we had. We cached some data when it was read by the transactions, and it happens once that after it was tried to commit and restart, these rows were not read, and this realization was behaving very badly. Don't do like we did.
Try not to use external state in between of transaction retries.
Yes.
Okay, so why does it keep it doing like this? We're almost on time, so just to leave you with a couple of ending notes and a couple of things which we take as our outcomes as our conclusions. So first of all, for a company like Nimses, when you have the goal to scale beyond a certain number of users and you have the ambition to maybe develop your own distributed database, think twice. It may be actually faster and more compliant with your goals to run on brackets someone else's technology, and these guys are the example of this. Second is when you adopt something new, whether it's Spanner or Kubernetes or whatever, it's always a way to lose time to try to adopt something that you know before in terms of the practices and processes and just stuff it into the new technology. It doesn't work like that. You have to learn the new right way, and with it you usually will get to the results. If you don't get to the results, come to the conference, come talk to us at Google, and we'll try to make sure that you're using the right things, because you guys eventually wanted to do Bigtable instead of Datastore. That would be fun. And getting back to the original points, Nimses counts every minute. We also strive to count every minute of our life and every minute of our time and put it to the best use. So we hope that with the right technology choice and with the right people around you, you will be able to do that. We're staying here. We're staying here for today. We're staying here for tomorrow, and there are more people actually from Nimses at the conference. So if you have specific questions on Spanner, Datastore, Kubernetes, and so on, just catch us and let's discuss it further. And right now we're just 2 minutes over time. So with this, I would like to thank you.